So today we have an interesting geometrical problem. We take a rectangle. Now we draw a pink circle such that it is tangent to three sides of the rectangle, as you can see in the diagram. Now we draw a yellow circle such that it is tangent to the pink circle and to the base of this rectangle. Now we draw a blue circle such that it is tangent to the two sides of the rectangle and also to this given circle. Now if the radius of the pink circle has been taken as A, radius of the blue circle as B, and radius of the yellow circle as C. The question over here is to find a relation between the radius of these three circles. So this is Anmol Mishra, and now let us see the solution. How can we solve this problem? So first of all, we can see that radius of these three circles are given as A, B and C. Therefore, as per the question, we have to find a relation between A, B and C. Now to get the required relation, we can take help of two things. The first thing is the data given to the tangent points, and the second thing is the arrangement of this diagram. So first of all, we'll see the data related to the tangent point. So in this pink circle, I will simply draw a radius to these two tangent points. Now as these points are tangent points, the angle over there would be simply 90 degrees. Now look carefully, the angle A, B, C and D would be 90 degrees because they are the corner angle of the rectangle. Now this and this quadrilateral, three of these angles are 90 degrees. Therefore by angle sum property, the fourth angle is also 90. This length and this length is radius of the pink circle, hence it would have a value A. Now this quadrilateral and this quadrilateral, all the four angles are 90 degrees and adjacent sides are equal. Therefore this both are squares of side length equals to A. Now this much length is A, this much length is again A. Therefore the complete length from A to the point D would be equals to A plus A, that is 2 times A. So here we can see that we have got the value of breadth of the rectangle, and that is 2 times A. So the other breadth, that is BC, would have the same value, that is 2 times A. Okay. Now look in this blue circle. I will draw the radius to this tangent point. The angle over there would be 90 degrees. This length is radius, hence it would have a value B. Over here we have again a square because all the four angles are 90 degrees and adjacent sides are equal. Therefore the distance from here to here would be equals to B. Now the complete distance is 2 times A. This much distance is equals to B. Therefore the remaining distance, that is from here to here, would be equals to 2 times A minus B. Okay. Now I will simply drop a perpendicular from the point Q to the base of this rectangle and label this intersection point as the point M. Now we can see that this angle is 90 by linear pair. This angle is 90 by angle sum property in this particular quadrilateral. Now this quadrilateral, all the four angles are 90 degrees, hence it is a rectangle. Therefore the length of opposite sides would be equal. This length is 2 times A minus B. So this length would also be equals to 2 times A minus B. Okay. Now recall the theorem that if there are two circles that are tangent to each other either externally or either internally, in both the cases, the center of both of these circles and the particular tangent point, these 3 points are always collinear. Either the case is external or either the case is internal. So here also we can see that all these three circles are tangent to each other. So if I simply draw a line segment joining the point P and Q, it will also pass through this tangent point. Now the distance from P to this tangent point is radius of the pink circle, hence it would have a value A. The distance from the tangent point to Q is the radius of the blue circle, hence it would have a value B. Now as these 3 points are collinear, means it is a straight line. Therefore the complete distance from P to Q would be ultimately A plus B. Now the same thing between the pink and the yellow circle. I can simply draw a line segment from the point P to R. This is the tangent point. This distance is A, this distance is equals to C. Therefore the complete distance from P to R becomes A plus C. Now again I will draw a line segment from the point Q to R. This is the tangent point, hence the distance from Q to R would become B plus C. B is radius of blue, C is the radius of yellow. Okay. Now what I will do is I will draw a line segment RN that is perpendicular to this radius of this pink circle. One more line segment RS that is perpendicular to the line segment QM. So here I have drawn these two external line segments. Now look carefully that this angle is 90 by linear pair. In this quadrilateral, by angle sum property, this angle is 90 degrees. The height of this rectangle is c, therefore this distance would also be equals to c. The complete white length is equals to a, this much length is equals to c, therefore the remaining length, that is this much, would be equals to a minus c. The same thing over here. By linear pair this is 90 degree, by angle sum that is 90. Here we have a rectangle, therefore the distance of SM would be equals to c. Now the complete distance from Q to M is equals to 2 times a minus b, we have discussed earlier. The distance of SM we have just got as c. Therefore, subtraction of this both will give me the distance of QS. You can see in the diagram, QM minus SM is equals to QS. Therefore, the length of QS would be equals to 2 times A minus B minus C. So here we have got the length of QS. Now in this diagram, take this triangle PNR that is present like this and this. The 90 degrees over here. The point P and R. The length of PR we have got as A plus C. The length of PN we have got as A minus C. Therefore, by Pythagoras theorem, the length of NR would be equals to 2 times square root of AC. Okay, keep this thing as it is. Now look in the triangle RQS that I am shading in white. The triangle is like this, this and this. Here is the 90 degree. The point Q, the point S, the point R. The length of QR is B plus C. The length of QS we have got as 2 times A minus B minus C. Therefore, by Pythagoras theorem, the length of RS would be equals to square root of B plus C the complete square minus 2 times A minus B minus C the complete square. And when you will simplify this equation, you will get the value of RS equals to 2 times square root of AB plus AC minus A square. This is the value of RS. So this time I will draw a line segment PO that is perpendicular to the line segment QM. Now look carefully in this particular quadrilateral. All the four angles would be 90 degree by linear pair and angle sum property. The distance from here to here is radius of the pink circle, hence it is A. Therefore this distance would be equals to A, and that is ultimately the line segment OM. Therefore the length of OM is equals to A. Now recall the length of QM, that is 2 times A minus B. The length of OM is equals to A. So if I subtract these two lengths, I will get the length of QO, and that would be equals to A minus B. You can see in the diagram, Q to M minus the length of O to M gives me the length of QO, and that is A minus B. So now look in this particular triangle that is over here. In this triangle, so let me draw it outside. So the triangle is like this, this and this. Here is the 90 degree, the point Q, the point P, the point O. The length of QO we have got as A minus B, and the length of PQ is equals to A plus B we have got in the beginning. Now by Pythagoras theorem, the length of PO would be equals to 2 times square root of AB. So here we have the length of these three line segments. Now to utilize this thing, we have to again go back to the diagram. Now look carefully in this particular quadrilateral, all the four angles are 90 degree by linear pair and angle sum property. Hence it is a rectangle. In rectangle, opposite sides are equal. Therefore the length of PO would be equals to the length of NS. So let me write it over there. So what we just got is the length of PO equals to the length of NS. Now look carefully that the length NS is divided by the point R. Therefore the length of NS would be equals to NR plus RS. Okay. So using this two equation, we will get the value of PO, that is NR plus RS. Okay. Now recall the three lengths that we have just got. So now we can simply put the value of this length in this equation. So the length of PO, so 2 times square root of AB would be equals to NR. So 2 times square root of AC plus the length of RS, that is 2 times square root of AB plus AC minus A square. Okay. Now 2 and 2 got cancelled out. I will move this term on that side. Therefore square root of AB minus square root of AC equals to square root of AB plus AC minus A square. Now to simplify this thing further, I will square both of this side. So square on the LHS will give me AB plus AC minus 2 times A times square root of BC. This thing equals to, now in the right hand side, square root and the square got cancelled out. So simply AB plus AC minus A square. AB, AC, AB, AC got cancelled out, and if I simplify the remaining two terms, I will get the value of 2 square root of BC equals to A. Now to simplify this thing further, we can simply square both of the side. So 4 times BC equals to A square, and that's the relation that we were looking for. Look carefully, we have got an equation in terms of A, B and C. So this was my way to solve this particular problem. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below. And if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.